Welcome to the shell method for finding volume using integrals. I'm Evan. The function we're going to be looking at is f of x equals 5x minus x squared, and we're going to revolve it around the y-axis. I've drawn a graph of the function on a piece of paper, and then I have a little demonstration here to show you of how it is revolved around. I have a drawing here of the function as it's revolved around the y-axis, and you can see the x-axis also in a solid line there, and the function there. And then there's the z-axis, the dotted line going back. This function, you could also picture it as a bundt cake shape. Focusing on the concept rather than this specific problem, I have a model I made up here. Pay attention to the layers that you can see there. Those are the shells, hence the shell method. And when I unroll this little model here, you will see that they lay out and then they look like rectangles, which we know how to find the area and the volume of said rectangles. It is these rectangles that we will be adding up to find the total volume using the concept of an integral. This is a view from above, so that's our z and x axes. The red line is the radius that we're going to select. And then that radius is then put in place of our x. Using this value, we can then find the length of one of the sides, the long side, the length, because it is the same as the circumference, and so we use that radius and just plug it into the circumference equation, 2 pi r. To find the height, one of the other sides, we just plug it into the original equation, f of x, which in this case, at this location, would be f of r. Now we want to find volume, so we need a third dimension, the width, which would in this case just be dx, which is infinitesimally small. It ends up looking like this rectangle where we have our height, circumference, and our dx as width. I'm going to jump back to the actual problem real quick here, and to remind you, it's 5x minus x squared is the function that we are revolving. I'm going to pick a point, a radius to use, and we are going to plug it in and solve for the volume of this specific shell right here. We're going to find the length of the long side first using the point x equals 3, and we plug that into the circumference equation, 2 pi x, 2 pi r, and we end up with 2 pi times 3, which is 6 pi. Now taking a look at the height with still the value of x equals 3, we plug it in, we get 15 minus 9 equals 6 for our height at that point. Next here, I just drew out that shell that we just calculated the values for and plugged in the values so you could see them. We have the length, circumference of 6 pi there, and then we have the height of f of 3, which is equal to 6. And then over in the corner there, you can see we have the width, which is equal to just our dx, our change in x. Breaking that into a formula just for any shell, you have 2 pi of your point k1 times f of k1 times your dx. This would be for a single shell, and so to find the overall volume, you would have to add every single shell together, which would be an infinite number because dx is infinitesimally small. This starts to sound a lot like a Riemann sum, where the limit of your dx approaches 0, which then you can turn into a definite integral on the interval from a to b. In the case of the shell method, you plug in your values and you get this set formula of 2 pi times the integral from a to b of your radius times your shell height times your dx. And your radius would be your x value in this case. I'll leave that up for a second and let you try to set it up using the function we are using, 5x minus x squared. So now you can go through and solve the integral from 0 to 5 with your x in for your radius and your function in for your shell height. Simplify, and within the integral you have a 5x squared minus x cubed dx, and then you anti-differentiate to end up with 5/3 x cubed minus x to the 4th over 4 on the interval from 0 to 5. You plug in the endpoints of your interval, simplify, and you get a nice 1250 pi over 12, which simplifies down to 327.249 units cubed for our bunt cake shape formed from the function 5x minus x squared. Thank you for watching.